Hello everyone, welcome to Reactify Labs. In this video, we will talk about Elasticsearch. Elasticsearch and Lucene. Okay. So, what is Elasticsearch? Why do we need Elasticsearch? What is something that it does which we were not doing without it, or which we were unable to do without it? Actually nothing. If you see it that way, there was nothing new that Elasticsearch is providing us. It's just that it's giving us the capability to do a fast search, which was otherwise not available with databases. Okay, so for example, let's say you have a database. Okay, big database, and let's say this is a database of books, and you have the name of the book, the author of the book, the year in which book was published, publication house, what is the ISBN. ISBN is, I think, International Standard Book Number, something like that. Yeah, it's book number, and IS is International Standard or something. Okay, so there are a lot of things. Now let's say there are so many books. Let's assume there are 1 billion books. Okay, so this search thing has 1 billion entries. Now if you need to search, for example, for what is that book, Game of Thrones, it's A Song of Ice and Fire. Okay, A Song of Ice and Fire. If you need to search for this book, and if you search, what happens is it will go and try to do string searching, right? String searching for each record. And because you have to know all the things, right? It's not that you just find one book and it will be it. Like, it is possible that something can be like A Song of Fire, Ice and Fire 1 or 2, but you only wrote this. So your search query needs to go through each entry in the database and search for it, right? And let's say instead you just wrote the name of the book as Song. So it's not the book, you just wrote the query as Song. It is possible that there is some person whose first name or last name is Song. So this entry will, query entry will return you a lot of things, including the book name, if any author's name matches with this song, or yeah, a lot of things. Or let's say there is some publication house which has song in it. So a lot of things will be returned, right? And if you have to do this query, going through 1 billion records in the database is a very costly operation, and it's going to make your system very, very slow. So what does Elasticsearch do? What Elasticsearch does is, whenever any entry comes in the Elasticsearch, okay, let's say a book came, a song, actually I don't know who the author is. Okay, R.R. Martin, I know. A Song of Ice and Fire. Okay, and you entered it with R.R. Martin, then you write the year something 1999, 1990, and a lot of other information. So when you enter this thing in Elasticsearch, what it does is it creates an index on a lot of things. It creates an index on year, it creates an index on R.R. Martin, it creates an index on each word, and a lot of things it does. So now when you have to query, let's say if you query song, the Elasticsearch already has an index on song. It knows that for song, matching song, there are a lot of things, including, let's say, this book, A Song of Ice and Fire, Volume 1, Volume 2, Volume 9, a lot of things. And also along with this, let's say there is some singer called, some person called ABC Song, or Song KLM. So these all are matched against this song, right? Similarly, for ice, if there is an index for ice, this index ice also has all these books, 1, 2, 3, all the versions of the book mapped against it. So whether you search for song or ice or fire, all these books will definitely be returned. Along with this, all the other books or the other authors whose name contain these similar words. So basically instead of now going through the entire database, what it needs to do is only search for this index. This index searching is very quick. As you know, the map search is very quick, right? So it's just a map search, like the key for this song or key for this word, and everything which is there, which is in the value of this key, will be returned. And that's what make it very, very fast. Okay. So I hope this gives you a very good high level overview of why do we need Elasticsearch. And now that why is clear, let's move to what and how part of it. Okay. So today we will follow this structure. First, we will start with the introduction of Elasticsearch. Then we will talk about Lucene. Then we will see Lucene query parsing, Lucene query parsing and search. Then we will see Lucene data structures. Then we will talk about Elasticsearch and Lucene integration. Elasticsearch and Lucene integration. And in the end, we will talk about some real world examples. Okay. Actually, before this, we will also talk about Lucene community and ecosystem. Lucene community and ecosystem. Okay. So let's start. What is Elasticsearch? You know what is Elasticsearch now. Let me give you now the technical formal definition of it. So Elasticsearch is a distributed RESTful search and analytics engine built on top of Apache Lucene, which is a high performance full text search library. It's a distributed RESTful search and analytics engine built on top of Apache Lucene, a high performance full text search library. High performance full text search library. Elasticsearch leverages Lucene's capabilities for indexing and searching structured and unstructured data, and provides real-time search, analytics, and visualization functionalities. Elasticsearch is commonly used for log and event analytics, enterprise search, content discovery, and application monitoring, powered by Lucene's robust indexing and search capabilities. I talked a lot about Lucene. What is Lucene? Let's see in this video, in this next heading. So next comes is Lucene. Apache Lucene is a Java-based open source search library. Java-based open source search library that provides powerful indexing. And search functionalities for building search applications. Lucene consists of core components such as analyzers, indexers, searchers, and query parsers, which work together to enable full text indexing and searching. Lucene's indexing process involves tokenizing, analyzing, and storing textual data in inverted index structures for efficient retrieval during search operations. So let's see what is the Lucene indexing process. Lucene's indexing process. First step is tokenization. Lucene tokenizes input text into individual tokens or terms based on predefined tokenizers and token filters, removing stop words and applying stemming or lemmatization. There are different things like stemming, lemmatization. These are some of the terms which we studied during our data mining lecture. Okay. So what is it? I'll explain. So let's see, there is a word called the man went to the jungle. Okay, so there are some stop words here. Okay, what it does is it first tokenizes into individual tokens. Let's say each word is made into a token. Okay, now it removes stop words. For example, let's say the, to, the. So these things are stop words, so it removes them. Next, it applies stemming and lemmatization. I am not very sure what stemming is and what lemmatization is. I'm a little confused here, but one of them is, what it does is, let's say if it is something like, so let's say the word is running. Okay, so what stemming does is, stemming just cuts it. Yeah, actually, yes, now I am sure what it is. Stemming just cuts it. Okay, cuts the ending of the word and brings the word to its base form. So it makes running as run. It makes runner as run, which is, you can say it's right or wrong, but this run is different from this run, right? This is a noun, this is a verb, so it cannot be same, but still this is what stemming does. It will just chop it off without realizing what is the meaning of the word. Okay, but what lemmatization does is, lemmatization will cut running into run, but it will not cut runner. Okay, it has to bring the word to its base form. For runner, it's a noun, this is the base form. For this verb, it's, since the base form of this verb running is run, so lemmatization does this, but this is not a verb, so it will not chop it off. Okay, so this is lemmatization and this is stemming. Okay, similarly, if we take another example, lemmatization also understands grammar actually. So if we see better, so it's, you know, that better, stemming will do nothing, but what lemmatization will do is, it will know that okay, the base form of better is good, so it will convert it to like this. Okay, and let's say if there is something called studying, so both stemming and lemmatization will make it study. Okay, so this is what stemming and lemmatization do. So Lucene tokenizes input text into individual tokens or terms based on predefined tokenizers and token filters, removing stop words and applying stemming or lemmatization. Next, it does analysis. Tokenized terms are analyzed and transformed into indexable tokens using analyzers, which apply text processing rules, character normalization, and language-specific algorithms. And then it creates an inverted index. Lucene builds inverted index structures from processed tokens, mapping terms to document IDs and positions, facilitating fast search and retrieval of matching documents. You might ask, why inverted index? What is inverted index? So let's say you entered something like at number 1, your first entry in your dictionary is, let's say, a book called book 1, or Harry Potter. Second is, let's say, a Song of Ice and Fire. So this is normal indexing, right? But inverted index is when you make like Harry Potter. Now you can say that, okay, this one is in library 1. So this is inverted index. You use this word to create an index. So that's why it's called inverted index. Okay. This is same thing which I explained to you in the beginning. Okay. Next, let's talk about Lucene query parsing and search. Lucene query parsing and search. So Lucene parses user queries into query objects representing search expressions, which can include Boolean operators, wildcards, proximity searches, and fuzzy matching. Lucene executes search queries against the inverted index, retrieving matching documents based on relevance scores calculated using term frequencies, document frequencies, and field boosts. Lucene's scoring algorithm ranks matching documents based on the relevance to the query, considering factors such as term frequency, inverse document frequency, and field length normalization. I am not going to go into the details of what TF is, term frequency is, what inverse document frequency is at the moment, because I don't think this is relevant from our point of view, because these things are usually asked when you are preparing for, let's say, NLP interviews, natural language processing interviews, or data mining interviews. So there you need to know these things. But for this video, that would be like too much deep, and you are not even expected to understand in that much detail. Okay. So like for the sake of these interviews, when you talk about Elasticsearch, you can just tell them how Elasticsearch uses inverted index to store the inputs so that the queries can be made faster, and that will be enough for you for system design interviews. So unless you are interviewing for NLP, you do not need these things. Okay. Now let's talk about the Lucene data structures. Lucene data structures. First one is term dictionary. Lucene maintains a term dictionary mapping unique terms to term IDs and storing metadata such as document frequencies and term positions. Next should be posting lists. Posting lists. For each index term, Lucene maintains posting lists containing document IDs and term frequencies, enabling efficient document retrieval during search operations. And next is document store. Document store. Lucene stores index documents in a separate document store, associating document IDs with stored field values for document reconstruction during search result rendering. Okay. Again, I am talking about these things in very high level because you don't need to know that much detail, but you should just know that, okay, there are these terms which exist. Okay. You should not be totally unaware of these things. And yes, you should not give much of your energy in understanding these things in detail unless you are specific, you are going for these NLP related roles. If you are just in the software engineering and you are preparing for system design interviews, not going into the details of these things will be good for you, because as they say, knowing what not to know is better than knowing what to know, right? Because if you know you should not know these things, you will not waste your time in studying those things. Okay. So just know about these things in high level. That's why I'm just talking about it and skipping them. Okay. Now let's see Elasticsearch and Lucene integration. These are good to know things. Okay. But not a mandatory thing. If you want, you can skip this video from this part. Okay. Elasticsearch and Lucene integration. But I would say I would request you to stay so that you have at least some high level overview, high level understanding of Elasticsearch and Lucene and how they make our daily life easier. Okay. So Elasticsearch and Lucene integration. First is Elasticsearch architecture. Elasticsearch integrates Lucene's indexing and search capabilities as its core engine, providing distributed search, indexing, and analytics functionalities. Next comes Lucene versioning. Elasticsearch incorporates specific versions of Lucene as its underlying search library, leveraging the latest features and optimizations introduced in each Lucene release. And next is performance and scalability. Performance and scalability. Elasticsearch builds upon Lucene's performance and scalability, distributing indexing and search tasks across multiple nodes in a cluster for high availability and throughput. Okay. Now let's talk about Lucene community and ecosystem. Lucene community and ecosystem. As we started this video by talking that Lucene is Apache Lucene. So Apache is open source. So Lucene's community must be very strong. Let's see. First one is open source community. Open source community. Lucene benefits from a vibrant open source community of developers, contributors, and users who collaborate on improving the search library, fixing bugs, and extending its functionalities. Next is ecosystem tools. The Lucene ecosystem includes a variety of tools, libraries, and extensions for building search applications, text processing, natural language processing, and information retrieval, and integration with Elasticsearch. Integration with Elasticsearch. Lucene's integration with Elasticsearch expands its reach and adoption, providing users with a scalable, distributed search platform for diverse use cases and industries. Now, let's talk about some of the real world examples and then we will end this video. Okay. Real world examples. First is enterprise search. Lucene, integrated into Elasticsearch, powers enterprise search solutions used by organizations like NASA, IBM, and LinkedIn to enable fast and accurate search across vast repositories of documents, files, and internal knowledge bases. Next is log analytics. Elasticsearch, leveraging Lucene's indexing and search capabilities, is widely adopted for log management and analytics by companies like Netflix, Airbnb, and Uber to monitor and analyze log data for operational insights, troubleshooting, and anomaly detection. Next is e-commerce and recommendations. E-commerce and recommendations. Lucene-based search engines are employed by e-commerce platforms like Amazon, eBay, and Etsy to deliver relevant product search results and personalized recommendations to users, enhancing the shopping experience and driving sales. Next is content discovery. Content discovery. Media and content platforms such as Spotify, YouTube, and Medium utilize Elasticsearch and Lucene for content discovery, enabling users to find relevant music, videos, articles, and multimedia content based on their preferences and browsing behavior. Okay. Next is healthcare and research. Healthcare and research. Lucene-powered search solutions are utilized in healthcare and research institutions like Mayo Clinic, NIH, and CERN for medical data retrieval, literature search, and scientific discovery, supporting clinical decision-making and research collaboration. And social media and networking. Social media and networking. Social media platforms including Twitter, Facebook, and Instagram leverage Elasticsearch search capabilities backed by Lucene to deliver real-time search results, trending topics, and personalized content feeds to millions of users worldwide. As you can see from the real-world examples, like almost every major system in the world is using Elasticsearch. With this, you can imagine how big or how difficult it must be to maintain Elasticsearch. Okay, and like how powerful that Elasticsearch is, that everyone is using that. This open source community which is maintaining Elasticsearch is doing a commendable job. Okay, and as I started this video by saying Elasticsearch does nothing which databases could not do. Yes, but still they are very popular. Everyone uses them. Why? Because they are making everything that database could do faster. They are making the searching, querying faster, which ultimately enhances the user experience. If a user needs to wait for 10 minutes after entering a search query, forget 10 minutes. Even if it's 10 seconds, the user experience becomes terrible. That's why the role of Elasticsearch in today's world in distributed systems having billions of users is very prominent. Okay. So now if you go back and listen to that word again, that sentence that Elasticsearch does nothing, you might say, why did I say that? Or if you just started that video and you already knew something about Elasticsearch, you would have definitely thought that, right? But yeah, again, I'm saying the same thing. Elasticsearch is not doing anything new, but it's just making the searching and querying faster, and which in turn enhances the user experience, which in turn drives the business value, which in turn drives the global economy. What else I can say? Okay, I hope this video gives you a good idea of Elasticsearch. If you already didn't know about this, why Elasticsearch, what is something that Elasticsearch is doing, what is the problem that Elasticsearch is solving, why did we need Elasticsearch, and what does it use, like that inverted index thing, what does it use to make these queries faster, why databases couldn't do it, and what different is it doing to make these queries faster, and what are some of the systems which use this Elasticsearch. So if you are going to draw any system, any system design of any system in your interviews, like WhatsApp, Instagram, or any, I talked about a lot of things, right? Spotify, Twitter, Facebook, Instagram, YouTube, Medium, all those things, any system which comes, and if you see it, it can leverage search capabilities, you can freely talk about the use of Elasticsearch there, and you can talk more and more. You can go deep if you want, if your interviewer wants, if your conversation is going good, you can go into the deep of Elasticsearch and you can talk all those things which I talked about in this video. Okay, so yeah, that's all there was in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.